So, good morning, friends. Welcome to Hydraulics and Hydraulic Machines class. So, in today's lecture, we deal with the governing of hydraulic turbines. Governing of hydraulic turbines means it is the way to maintain the speed of the turbine as constant under all varying load conditions. The mechanism by which we keep the speed of the turbine as constant irrespective of the load is what we call it as governing mechanism. It is very, very important in case of turbines. Generally, this governing mechanism is automatically done by the governors which are coupled to the turbine shaft. Next. Why, sir? Why governing is necessary? Why governing is necessary? The reason being, you imagine any turbine is coupled to generator through a shaft. The generator will be rotating at some speed. If suppose suddenly the load on the generator decreases, load on the generator decreases. Load on the generator decreases means what? That means the power supplied by the generator is not being utilized and there is no requirement of power to that extent. So the load on the turbine is reduced. When the load on the turbine is reduced, automatically the generator speed will be more than the normal speed. Why? The moment actually for X load, the generator is revolving with some speed, N. We call it as normal speed. Suddenly that X load has decreased. Then what will happen? The speed of the generator increases. If the speed of the generator increases, we have to make it constant. Why? Because the frequency of power generation should be constant. For a constant number of pairs of poles, the frequency of power generation has to be maintained constant. If you want to maintain that constant, the speed of the generator should be at normal speed only. But now, because of the reduction of the load, what has happened? The speed of the generator has increased beyond normal speed. Then what to do? How to bring that generator speed to normal speed? Then actually we know that this generator is coupled to a turbine. When this generator starts rotating at a higher speed than the normal speed, automatically as it is connected to the same shaft, the turbine also starts rotating at a higher speed. So when turbine also starts rotating at higher speed, then how to bring that speed to normal speed is our problem. Then what we will do is we use this governing mechanism and control the flow. We control the flow. We reduce the flow. The moment we reduce the flow, the speed of the generator reduces and comes to normal speed. When the turbine speed comes to normal speed, automatically the generator which is coupled to it, they are all synchronous. The turbine and the generator are synchronous. They together rotate at a constant speed. So automatically the generator also rotates at a constant speed. So how this all this has happened because of the control of flow onto the turbine. So that control of the flow onto the turbine is done by the governing mechanism. This is first point. Think in the other direction. Suddenly the load on the generator increases. What happens? Suddenly the load increases. The power consumption requirement has increased suddenly. Then what happens? The speed of the generator reduces than the normal speed. So it reduces below the normal speed. When it reduces below the normal speed, naturally the same shaft the turbine is connected, the turbine speed is also reduced. But we cannot allow that automatically. We should make that the turbine rotate at normal speed. How to make it to rotate at normal speed? What will happen? We use the governing mechanism and we allow more flow onto the turbine. Again, the flow control, more and more flow we allow onto the turbine. Thereby, the turbine speed becomes normal speed. And when once turbine speed becomes normal speed, automatically the generator speed also becomes normal speed. So this is under vary whether the load increases or load decreases. The speed of the generator has to be maintained at constant speed, and that is what we call it as governing mechanism. The speed of the generator is maintained at constant speed only if the speed of the turbine is maintained constant. So that's why both should be synchronous. Synchronous means both are to the same turbine. If one changes, the other changes. So that is why, that's how the speed is to be maintained constant. How we can make this turbine and generator together work at normal speed is by governing mechanism. So this is what we call it as the governing mechanism, which is a very very important subject, which is in this particular hydraulic turbines. So this is the thing. Let us go how it functions, how it works, what is the figure for it, how the real thing will happen. That I will show you for one turbine. I will show you for the what you call it as the impulse turbine, how it happens automatically. You can see for the reaction turbine also. I have shown in the figure so that you can follow it. Okay, thank you. Let us go into the discussion point of view. So the topic is governing mechanism in hydraulic turbines. What do you mean by governing means operation by which the speed of the turbine is kept constant under all conditions of loading. This is what we call it as this. And this is done automatically by the governing mechanism. By the governing. What happens in the governing mechanism? Control of the flow. Finally, governing mechanism it means actually control of the flow. Control of the flow for what actually? Control of the flow for maintaining turbine speed constant. This is what it is. Then, why governing mechanism? Why governing? Turbine is coupled to what? Turbine is coupled to generator, right? First, generator and turbine rotates at normal speed. They are synchronous. So, if the load on the generator, this is very crucial point. If the load on the generator decreases, let us assume, then generator speed increases beyond normal speed. Immediately, as the turbine is coupled to generator, the turbine speed also increases. Kindly see the first thing. If the load on the generator decreases, load on the generator decreases, meaning is what? Load on the generator decreases means actually the meaning is the power generation requirement has basically reduced. We need not produce the power at that load. So power generation requirement has reduced. When power requirement is reduced, the load on the generator, we say it is decreased. When the load on the generator decreases, the generator speed increases beyond normal speed. So it will be generator will be rotating at some constant speed, which we call it as normal speed. The turbine, the generator is coupled to the turbine. So the turbine is also rotating at normal speed. For the rotation of the turbine at normal speed, we are naturally controlling the flow onto the turbine. So based on that, the flow control makes the speed of the turbine as a normal speed. Automatically, as it is connected to the same shaft, the generator speed also becomes normal speed. So this is the process, regular process. Now suddenly what has happened? The load on the generator decreases. When the load on the generator decreases, what has happened? The generator speed has increased beyond normal speed. When the generator speed has increased beyond normal speed, naturally the turbine which is coupled to the generator, its speed also increases beyond normal speed. So that means both the turbine and generator are working beyond normal speed. When both of them are working beyond normal speed, which should not actually, so they have to be brought down to normal speed. How to bring down to the normal speed? What we will do, we use the mechanism, governing mechanism, and bring the turbine speed to normal speed by controlling the flow of water onto the turbine. When once you control the speed of the turbine and make it normal speed, the coupled generator to the turbine also becomes works at normal speed. This is what we call it as governing mechanism, and this is done. Similarly, if the load on the generator increases, the speed, the naturally the generator speed reduces below the normal speed. When it reduces below the normal speed, the turbine speed also reduces. So, in order to bring the turbine to normal again, the flow has to be controlled. That means what we need to supply more and more water onto the turbine, and this is done by the governing mechanism. The next question you may ask, why we need to maintain the speed of the turbine or generator as constant? Why? Because the frequency of power generation has to be maintained constant. If you want to maintain the frequency of power generation as constant, which is equal to P into N by 60, where P is the number of pairs of poles and N is the speed of the generator. So if you want to make it which where this F should be maintained as 50, automatically this N should be constant. So under whatever is the working condition, this N should be constant. N cannot go beyond normal speed and cannot become below the normal speed. So that is why the governing mechanism is a must in the case of any turbine, to bring to see that the turbine speed is at a constant speed throughout, irrespective of whether load on the generator decreases or whether the load on the generator increases. This speed cannot change. So that basically this governing mechanism is necessary. Please remember that this governing mechanism is an automatic mechanism that happens in the case of the turbines. So now I will show you in the case of Pelton turbine what happens actually. In the case of Pelton turbine, we use the oil pressure governor for that. The oil pressure governor is used for governing mechanism in the case of Pelton turbine. So before going into it, what are the components? The various components are: one is oil sump. There will be a storage of oil, that what we call it as oil. So that means with some viscosity. Then naturally there will be a pump to pump this oil into basically the mechanism, into the governing mechanism. That is what we call it as gear pump. There will be a servo motor actually, a relay cylinder in which what will be there in this relay cylinder. In this relay cylinder, there will be a piston actually, and the piston will be is connected to the spear rod actually, and at the end the spear will be there, and the spear will be moving into the nozzle, into it or out of it. So naturally, depending on the oil pressure on basically the piston both sides, the spear rod will be moving in this servo motor. This servo motor or the relay valve, wherein the piston will be moving, the piston which is connected to the spear rod will be moving inside or basically away from it, so that the flow can be controlled. Then the fourth component is the control valve. The control valve is basically a cylinder again, wherein two pistons will be there, and these pistons actually will be working, allowing the flow into valves V1 and V2, depending on basically whether the spear rod has to be pushed inside or spear rod has to be pushed back. Then the centrifugal governor. The centrifugal governor is nothing but actually a sleeve and a flyball mechanism, wherein actually the depending on the speed of the turbine, whether the flyballs will move up actually, or flyball moves down. It's like an umbrella, where the umbrella gets open or umbrella gets closed actually. And pipe connections, naturally the oil connection basically to the, whether it is the control valve or servo motor, these are pipe connections are required. And already I mentioned the servo motor already, where there is a piston which is connected to the spear rod and needle, and this will be operating in the nozzle of the nozzle connected to the penstock. So the nozzle opening is controlled by the spear, basically connected to the spear rod. So now let us come to the figure. First component that you should draw is the oil sump. First, draw the oil sump. Once you draw the oil sump, that means wherein oil is filled.
there will be three pipelines which are coming basically from the oil sump. These three pipelines are connected to the control valve. That is the first thing. In this, actually, in the central one, the pump oil will be pumped by the gear pump into the control valve, whereas the other two, the oil will be taken back from the control valve to the sump. Both the other things are basically to take that back. The next, what will happen first? Again, here there are two valves V1 and V2. These are the two valves. Again, two pipelines. One pipeline is connected to on the left side of the piston in the servo motor. The other pipeline is connected to the right side of the piston in the servo motor. Now, this control valve basically rod is connected to a lever, horizontal lever, and at the horizontal lever end, one end is connected to the sleeve. Sleeve is nothing but a vertical rod, actually, which is directly connected to the turbine main shaft. So, and the sleeve on the up at the top of the sleeve, we are having the centrifugal governors with fly balls. Now what happens, actually, let us start discussing this. So the gear pump actually operates and pump the oil from the sump to the basically to the control valve. Into the control valve it pumps, so this is filled with oil, actually, right? That is first thing. Then second thing is what? When the load on the generator is decreased, then the generator speed will be increasing beyond normal speed. So the turbine speed also increase beyond normal speed. When the turbine speed is more than the normal speed, naturally what will happen when the turbine speed increases beyond normal speed? This basically these fly balls, the centrifugal governor which is connected to the turbine shaft, naturally starts opening up. When it gets opened up, this is the position how it looks like, actually. The balls which is initially which are like this, they move up actually like this. So when they move up, they push the sleeve upwards. These are the blue things which I mentioned. Naturally, the sleeve moves upwards. That means the lever rod moves upwards on the left side. When lever rod moves upside, the fulcrum, the other side of it, which is based on that fulcrum, naturally the other side goes down. When it goes down, actually, it closes the valve V1 and opens the valve V2. When the valve V2 is open, the oil enters with the pressure on the left side of the piston of the servo motor, and then on this side it starts work applying pressure. When it starts applying pressure here, naturally the spear is pushed front. When the spear is pushed front, naturally it closes the nozzle or it reduces the nozzle opening. So when it reduces the nozzle opening, the flow is controlled. The flow is controlled means the flow is reduced. When the flow is reduced, the turbine speed is brought back to normal speed. When the turbine speed is brought back to normal speed, automatically the generator speed also becomes normal speed. This is one part of it. The second part of it is, if suppose, for example, the load on the generator increases. When the load on the generator increases, the fly balls will come closer, and naturally this is how the fly balls is going to be. When the fly balls are in this position, the sleeve is moved downwards. When the sleeve is moved downwards like this, sleeve is moved downwards like this on left hand side. Naturally on the right hand side the lever is moved upward. When it is like that, this valve V1 gets open. That's what I told. This valve gets open, and now the oil pushes the black dots you see, and now the oil enters onto the right side of it. When the oil enters onto the right side of it, it pushes the piston backwards. That means the spear gets opened up. When the spear pushed it back, the nozzle gets opened up. When the nozzle gets opened up, automatically the flow onto the turbine increases. When the flow onto the turbine increases, the speed of the turbine increases. When the speed of the turbine increases, when the speed of the turbine increases automatically. Now what will happen then? Naturally it's thus becomes normal speed, and the generator speed also becomes the normal speed. So both the cases we should understand, when load up on the generator decreases, speed increases, so we have to reduce the speed. When the load on the generator basically increases, speed decreases, now we have to increase the speed. For increasing the speed of the generator or decreasing the speed of the generator, only the turbine speed has to be controlled. How the turbine speed is to be controlled? It is only by governing mechanism. How the governing mechanism helps us? The governing mechanism controls the flow of water entering onto the turbine. So that is being done by the governing mechanism. So this completes the governing mechanism in the case of impulse turbines. Whereas if you take the reaction turbines, in the case of reaction turbines, the same thing naturally we make it connected to the guide blade mechanism, because rather than spear and nozzle, which is in the case of the Pelton turbine, there we have the guide blade mechanism, and now we operate the guide blade mechanism basically depending upon the loads. The flow is controlled at the guide blade mechanism in the case of reaction turbines. So in the case of the reaction turbines, if you see, what we will do is the flow control happens. The flow control happens at basically the guide blade mechanism. We changes the width between the veins, and thereby the we increase the flow or decrease the flow, thereby basically the speed can be maintained. So this is the governing mechanism in case of turbines. So kindly go through that. Figures are very very important. Both the impulse turbine and reaction turbine, both you need to really follow it. So work on that. This is a short notes that which is very important in the case of
Like, share, and subscribe. Hit the bell icon for more updates.